Let's take a look at adding and subtracting radical expressions. So you could almost kind of think about this as adding or subtracting like terms. So what we want is like radicals. In order to combine them, to add them, to subtract them, we need to have the same index and the same radicand. So let's take a look at our first example, A. Now here we have the square root of 20 and the square root of 5. Now those have the same index but not the same radicand. My radicand here is 20, my radicand here is 5. We also have some cube roots, so index is the same, however the radicands are not. So what we're going to do is we are going to simplify each term, and then we're going to be able to combine if we have the same radicand. So here we go. First thing I'm going to do, I'm just going to group my terms by index. So I have an index here of 2. So I'm going to write the square root of 20 just to keep things nice and neat. And I have a minus square root of 5. Next up, let's do my cube roots. Minus the cube root of 16 plus the cube root of 250. And now let's start simplifying. So looking at square root of 20, I want to think of factors of 20 that when that are also perfect squares. If I'm looking at a square root, I want perfect squares so I can simplify. 20, if you think about factors, that is 4 times 5. And don't forget, 4 is 2 squared, so your exponents would cancel out. I can't do anything with the square root of 5. You can't simplify that anymore. Now I'm moving into the cube roots. So cube root of 16, I need factors of 16, where one of them hopefully is a perfect cube. And I am right away thinking of 8. 8 is a factor of 16, and it's also a perfect cube. 2 to the third power is 8. So I'm just going to go ahead, let's write this as 8 times 2. Now, cube root of 250. Well, again, I'm thinking I need factors that are a perfect cube, and I'm thinking 125 times 2. If you remember, 125, we've seen this a few times in our lessons. 125 is 5 raised to the third power. So here we go. Let's just start simplifying. Square root of 4 is 2. That 5 stays underneath the radical. I can't do anything with the square root of 5. That stays. The cube root of 8 is 3. So this is, is 2. 2 cubed, 2 to the third power is 8. 2 times the cube root of 2 plus the cube root of 125 is 5. And then we have times the cube root of 2. I can't reduce that 2 anymore. And so now what we're going to do, it's almost like combining like terms. You can almost think of like this 2 almost as a coefficient. It's technically not, but you're just taking the numbers outside of the common radical. We have the common index and the common radicand. So here I have 2 times the square root of 5 minus 1 times the square root of 5. So 2 minus 1 is just 1. Let's go ahead and let's write this off to the side for the sake of being clear. And now here, I have negative 2 and a positive 5. Negative 2 plus 5, and I'm just keeping my index and my radicand. And so now when we simplify this, I have 2 minus 1 is 1, so I have the square root of 5. Now negative 2 plus 5, well, that's a positive 3 times the cube root of 2. Final answer. Now let's take a look at these triads. These are going to take a little bit more work. They're not as straightforward as our first example. So let's go ahead and break it down. First, I'm going to just move this. I'm going to get my my index of 2 moved over, and then I'm going to group up my index of 3. So I have the square root of 2. Do not need to write that 2 there. I had it on my brain. 2 plus the cube root of 2,000 minus the cube root of 128. Now the square root of 2, I just can't do anything with that. I'm going to leave it be. Now the cube root of 2,000, that might not always be something that those numbers, those factors are just going to pop out in your head. So here's what we're going to do. We're going to do some work off to the side, and we're going to completely factor out the radicand and see what we have. So 2,000. I'm going to do a factor tree. 2,000. I'm going to say 20 times 100. And that might not be the factors that you choose. That's okay. Just keep factoring until you can't factor it out anymore. 20 is 4 times 5. 100, let's do 4 times 25. You could do 10 times 10, that's fine. Again, just keep factoring it out. So now 4 is 2 times 2. I can't factor that 5 anymore, so that's just 5. 4 is 2 times 2. 25 is 5 times 5. Okay, so I am factored all the way out. I cannot factor this anymore. So now let's see what we have. Remember, we're looking for a cube, so we're looking for a group of 3 of the same number. Let's see what we have. Okay, here's 1 2, 2 2s, 3 2s. So here's a 2 cubed. I'm just going to go ahead and draw a line through those so we know we have them. And I have 1 extra 2 hanging out, so times 2. Put my line through there. I got him. Now what's left? I have 1, 2, look at that, 3 5s. So this is times 5 to the 3rd power. And I know when I go to simplify that radical, because I have these exponents here of 3, these 2 bases are going to be able to leave the radical. So let's write that in. We've got plus the cube root of 2 to the 3rd times 2 times 5 to the 3rd. Now let's work with this 128. Let's factor this guy as well. Now when I look at 128, right away I think of a factor of 4, and I think of that because I see 12 is divisible by 4, and so is 8. You might not see it that way, and that's okay. You can use different factors. You could even start factoring it, divide it by 2, and just keep going until it's factored all the way. So 128 is 4. Let's see, 12 divided by 4 is 3, 8 divided by 4 is 2. 4 times 32. And now let's just keep factoring this. 2 times 2. And 32 is 4 times 8. So 4 is 2 times 2. 8 is 2 times 2 times 2. So now let's see, what do we have? And again, remember, you're looking for groups of 3. So I have, here's a group of 3 2s. And here's a group of 3 2s. So that means here I have 2 groups of 2s, 2 groups of 3 2s. That's a mouthful to say. times 2. We have 1 left over. And keep in mind too, here we have 7 2's, so this is 2 to the 7th power. And if you divide 7 by 3, you get 2 with a remainder of 1. And again, if you apply your properties of exponents here, just to double check yourselves, power to a power, you multiply your exponents. So this is 2 to the 6th power times 2 to the 1st power. 6 plus 1 gets you the 7. So here we go. Let's drop this in and see where we're at. Cube root of, I'm going to go ahead and write this. This is 2 squared. 2 squared is 4. So let's just right now. 4 cubed times 2. Okay, so now let's start simplifying. And again, the square root of 2, we can't do anything with it. Now here's where we can start breaking things down. Wherever I see that exponent of 3, remember, your index cancels it out and your base can leave the radical. So now here, and now what happens when you have more than one number, one factor that you're pulling out, when you pull it out, you're going to multiply them. So this is 2 times 5 times that 2 can't leave. So this is times the cube root of 2 minus, okay, and now here again, this index and the exponent, they're inverses, they cancel each other out, and what is that base can leave the radical. So I'm going to pull out a 4 times the cube root of 2. And now let's take the final look here. Got a few more things to do. We have the square root of 2. 2 times 5 is 10 times the cube root of 2 minus 4 times the cube root of 2. Almost there. So now let's go ahead. We can combine these. They have the same index and the same radicand. So my final answer is the square root of 2. 10 minus 4 is 6 times the cube root of 2. Let's take a look at B. So B, this is all square roots. So let's simplify. Square root of 20, we already did that in our first example. Square root of 20 can be written as 2 times the square root of 5. Now 600. Let's break down 600. Let's go 6 times 10. We're going to do this one a little bit faster. 6 is 2 times 3. 10. Oops, this is 6 times 100, excuse me. 10 times 10. 2 times 3 times 10 is 2 times 5 times 2 times 5. So there we are. So now let's see, what do we have? And again, remember, you're looking for groups of 2. So I have, let's see, how many 2's do I have? I have 1, 2, 3. So that means I have 2 squared times 2. I'm grouping them in 2's. Okay, so I've got that covered. I have 1, 3. And now I have 5 times 5, which is 5 squared. Again, that's a group of 2. I'm going to go ahead and write this underneath the radical. Minus the square root of 2 squared times 2 times 3 times 5 squared minus, now let's tackle the square root of 25. So square root of 25, let's break down 125. We already know that 5 to the third power is 125. We've worked with that several times. So that means this is going to be 5 squared times 5. And now let's clean this up. I can't really do anything with this 2 times the square root of 5. I have minus. Now what can come out? Wherever you have that exponent of 2, those bases can come out. So here I have, and I'm going to go ahead and write this all the way out. I mean, you could just write minus 10, but let's just do this for the sake of showing step by step. Times, now what is left in here is a 2 times 3, which is 6. Minus, now here again, this base of 5 can come out. 5 times the square root of 5. And now let's clean this up. 2 times the square root of 5 minus 10 times the square root of 6 minus 5 times the square root of 5. So now notice these, my first term and my last term, are the only 2 terms I can combine. They have the same index and the same radicand. So 2 minus 5 is a negative 3. So this is going to be negative 3 times the square root of 5 and minus 10 times the square root of 6.